This video is about LeChatelier's principle. Make sure you have your fill in the blank notes ready because this is the video that you're going to use to fill in those notes. First of all, let's define reversible reactions. A reversible reaction is one in which the products can regenerate the reactants, which means that you can either start from your reactants and make products, or if you have your products, you can go backwards and remake those reactants. Equilibrium is a definition that you need to know. It occurs when the rate of a reaction happening in the forward direction is equal to the rate of the reaction happening in the reverse reaction. So equilibrium is reached when the rate at which products are being made is equal to the rate at which reactants are being made in reversible reactions. So LeChatelier's principle says that if a system that is in equilibrium, like we just saw in the last slide, if it is disrupted, the system will shift to reestablish the equilibrium. Just like in the picture, you have the two people on a seesaw. One person goes down, the other one goes up. Well, you can reverse that, and the person who's up can go down, and the person who's down will go up. So that's kind of an analogy to picture how LeChatelier's principle works. There are three things that you can do to disrupt equilibrium. The first one we're going to talk about is change in concentration of a reactant or product. So if you add more reactant or product, it doesn't matter which one, the system will shift to consume the added substance. Or if you take away some of the reactant or product, the system will shift to make that substance again. So if we look at A as our reactants and B as our products, and the double arrow in the middle, that's a representation to show that the reaction's in equilibrium. So if we add more of A, so if we increase the concentration of A, which direction will this reaction shift to reestablish the equilibrium? Well, the answer is it will shift to the right, because what you want to do is use up all that extra A, so all the extra reactant that you added in, and it will shift to the right in order to use it up and reestablish equilibrium. Now let's look at this reaction, 2A plus B, and then it's in equilibrium, so we have the double arrows again, produces 3C plus D. Well, if we take away some of D, which direction will the reaction shift? Well, the answer is it will shift to the right because it's trying to replace D that you removed, whatever product D is. So it's going to shift that direction to make more of that and reestablish equilibrium. The second thing that we're going to talk about that we can do to disrupt equilibrium is change in pressure. So the general rule for this is that if you increase the pressure, the system will shift to decrease that pressure. And if you decrease pressure, the system will shift to increase the pressure. So if you increase the pressure of this system, which way will it shift? So we have 2A and it's in equilibrium producing B. Well, the answer is that it will want to decrease pressure. So increasing pressure, you're going to do the opposite. It's going to decrease the pressure. So it will shift to the side with fewer number of moles. That's the kind of key thing for pressure, is that it will shift to the side that has fewer moles of gas. So if you're increasing pressure, it goes to the side with fewer moles. If you're decreasing pressure, it goes to the side with more moles. And it's important that you note that they are moles of a gas. Whichever one has the, in this case, since we're increasing pressure, it will shift to the side with the fewest number of moles of gas because it will exert less pressure. So in this one, it will shift to the right because there's only 1 mole of B and there's 2 moles of A. In this one, if we're decreasing the pressure, it's going to shift to the side with more moles of gas, which would be the right side, because there's 3 moles of C and 1 mole of D, which is a total of 4 moles of gas, unlike on the left side where there's a total of 3 moles. The third thing that we can do to disrupt equilibrium is change in temperature of the reaction. Now, this is dependent on whether the reaction is exothermic or endothermic. So if the reaction is endothermic, you will see the heat is on the reactant side. If it's exothermic, you'll see the heat is on the product side. So if we add heat, it's going to consume that heat. If we remove heat, it's going to work to bring it back. So this rule kind of works exactly like the first one that we talked about with changing concentration. So if this reaction here, A to B, is exothermic, which way will the reaction shift if the temperature of the system increases? Well, since we know it's exothermic, that means the heat is on the product side, and the reaction is going to shift to the left to make up for that extra heat that you added. It shifts away from the heat. If we look at this reaction and we know it's endothermic, well, we know the endothermic reaction has heat on the left side of the arrow, and if we are going to decrease the temperature of the system, the reaction is going to shift to reproduce the heat that's lost, so it's going to shift to the left to make up for and add more heat. And there's one more thing you need to know about equilibrium, and that's the equilibrium constant, which is K, and then EQ standing for equilibrium. And in this case, the only stress that changes this value is the change in